Why does implicit differentiation exist? Well, up until today, what kinds of equations have we been working with in calculus? So I'm going to write out 4 equations, and you tell me what they all have in common. What do these equations have in common? Y is by itself. Okay. So we know how to find the derivative of all these equations. Now, what would happen if y was not by itself? How would we find the derivative then? We need a new method to do that. And that new method is called implicit differentiation. Now, this new method is very similar to what we're used to doing. How do we differentiate this equation? So I'm going to take the derivative with respect to x of both sides of this equation. Okay, so I just took d dx of both sides of this equation, and what am I going to get here? So this is the same thing as dy dx. Right, when we take the derivative, we get dy dx. And then if we're going to take the derivative with respect to x here, what's this going to turn into? It's going to be 4x plus 5. Now, if you need a refresher on how to do these, I have a video on that. Okay, so that's how to solve these. And earlier I said the way we do these, the way we do implicit differentiation, is very similar to what we're used to. Okay, so what's that going to look like? Well, our first step is identical. We're going to take d dx of both sides of the equation. And so we're taking the derivative with respect to x of both sides of this equation. What's the derivative with respect to x of x squared? (2x), and then a plus sign here. And then what's d dx of y squared? So d dx of x squared is 2x, d dx of y squared is 2y, and then I also have to include a dy dx here. So 2y times dy dx, and I'll explain why the derivative of y squared with respect to x is equal to this in the next video. So you understand why this stuff works in the next video? Just take my word for it for now. What is the derivative with respect to x of 25? Zero. Okay. Now, so that's this part. This part's very similar to what we're doing over here. And then over here, you'll notice that we have dy dx by itself. So our next step here is also to get dy dx by itself. Now, how do we do that? Okay, so we're going to keep everything that has dy dx on one side of the equation, and then we're going to try to get everything else that does not have dy dx to the other side of the equation. Okay, so to do that, I'm going to subtract 2x from both sides of this equation. And now, how do I get dy dx by itself? I need to divide both sides of this equation by 2y. And these cancel, so dy dx is equal to negative x over y. But yeah, don't worry too much about this step here. Don't worry too much about how come d dx of y squared is equal to 2y times dy dx. We'll cover that in the next video, and here's what else we will talk about. So you'll learn why d dx of y squared is equal to 2y dy dx. And you'll also learn how come d dx of y cubed is equal to 3y squared dy dx. You could also say d dx of y to the power of 4 is equal to 4y cubed dy dx. And you might be noticing a pattern here, right? This is very similar to d dx of x squared. And this is very similar to d dx of x cubed. This is very similar to d dx of x to the power of 4. But yeah, you'll learn why this works in the next video. And I'll see you there.